Well, I decided to take a speed run to this recent specialist maths exam 1 for NHT timetable. So students have 15 minutes reading time and 1 hour writing time. Let's see how we go. Question 1 4 marks. A certain model of electric car accelerates in a straight line from rest. Its constant acceleration to travel 400 meters in 10 seconds. Find acceleration in meters per square second. So let's say S equals to UT plus half AT squared. Well, 400 meters equals to 0 times 10 plus half times A times 10 squared. So pretty much you have 400 equals to, let's say, 58, 100 over 2. So A equals to 8 meters per squared second. Constant acceleration, nothing special. And find the speed of the car when it has traveled 400 meters. So I'm using V equals to U plus AT. As long as it's a constant acceleration, good. 0 initial velocity times 8 times 10. So it's 80 meters per second. The second car accelerates in a straight line from rest with a constant acceleration for 12 seconds. Given that the speed of the car is V meters per second after 12 seconds, write down the average speed of the car in terms of V for the first 6 seconds of this motion. What I'm going to do is like a VT diagram. So this is small v, this is t. And let's say after 12 seconds, it accelerates to a capital V. Okay, but if you notice the symmetry here, I suppose, in the middle, I've got half V. So pretty much you want to find the average speed of the car in terms of V for the first 6 seconds. Okay, I probably would just use, the first 6 seconds because pretty much this is like a triangle. The area under the triangle is, let's say 3V, okay? 0 to 6 seconds. The distance equals to half times, let's say 6 times half V. So it's going to be 3 over 2 V. And average speed equals to 3 over 2 capital V divided by 6. So it's 3 capital V divided by 12. And that is V over 2 meters per second. Oh, sorry, V over 4. Okay, so pretty much that is part B. Let's move on. Solve z to the power 4 equals to minus 8 plus 8 root 3i. Answer in Cartesian form. Let's say, okay, where is this complex number? Minus 8, 8 root 3. So we pretty much get a triangle like this. And this is the location of the complex number. And if you use a special triangle, this will be 16, okay? 1, 2, root 3. Pretty much you multiply everything by 8. So the angle should be 2 pi over 3 in the second quadrant. Therefore, I'm going to get a z to the power 4 equals to 16 cis 2 pi over 3. Okay? Now, I probably need to rewrite the polar form, like 2 to the power 4 cis 2 pi over 3 add 2k pi. And this k value can take 0 plus or minus 1 and plus or minus 2, etc., etc. So once I take the fourth root, I should be able to get a z equals to 2 cis divided by 4, the angles. So 2 pi over 3 divided by 4 is pi over 6 plus k pi over 2, I suppose. So we can actually write this in a more elegant form, taking out a pi over 6, 1 plus 3k. So now, if I trust k equals to 0, z is 2 cis pi over 6. K equals to 1, z equals to 2c's, 4 pi over 6. And that is 2c's, 2 pi over 3. And if I have k equals to -1, I've got z equals to 2c's minus 2, actually -3 plus 1 minus 2. So minus 2 pi over 6. That is 2c's minus pi over 3. And if I sub in the last number, I suppose I should get a -2 for principal angle. So I would say, okay, this is -5 pi over 6, okay? So the first one gives me, let's say, √3 plus I, okay? So that is the first Cartesian form. Next one, if you draw a diagram, it's here, -1, √3. In the second quadrant, so minus I plus I √3. That's the second solution. And the 2c's minus pi over 3 is here. Actually, if you recognize the symmetry, it's sort of easier. You could say this is 1 plus, actually, bear with me, 1 minus I √3. It's the third solution. And the last one, this will give you minus √3 minus I, okay? So that's number 4. Pretty much that's a very standard complex number question. Let's move on. Find the coordinates of the points of inflection of the graph. So dy dx equals to 4x cubed minus 12x. And the second derivative is 12x squared minus 12 equals to 0. X squared equals to 1 and x equals to plus or minus 1. Notice that the two terms here, x to the power 4 and x squared, will make -1, +1. So y plus or minus 1 equals to plus or minus 1 to the power 4 minus 6 plus or minus 1 squared plus 4. Eventually, it's just 1 minus 6 plus 4. Minus 1, I suppose, 5 minus 6 minus 1. So the points of inflections plus or minus 1 and a -1. Or you can state them separately. Hence or otherwise find all values of x for which the graph is concave up. Concave up here, technically speaking, I would try to use second derivative greater than or equal to 0, or you could say d2y dx squared is greater than 0. This is a bit ambiguous, to be honest with you. But what I'm going to do is identify the shape of this graph. Well, if you look at y equals to x to the power 4 minus 6x squared, it can be written as, let's say, x squared minus 6. So x squared, x minus √6, x plus √6. Well, the shape is like this. This is a quartic function, okay? And pretty much you will identify, let's say, ignoring the +4 here as a vertical translation. This is -1, this is 1, indicating the points of inflection. And you want the values of x for which the graph is concave up. So from -infinity to here, from here to +infinity, okay? So if I do not count, let's say, the two x values for point of inflection, I should just get x less than -1 or x greater than 1. If x values or POIs were excluded, okay? But to be honest, you could also argue x is less than or equal to -1 or x is greater than or equal to 1, okay? In this case, I just follow these inequality here, okay? Question 4. Find the coordinates of the point where the line given by the equation I equals to 4 minus 2 plus t times 2 minus 1, 3 intersect the plane with the equation 2x plus 3y minus z equals to 6. So firstly, I will convert the vector form into parametric form. There are 3 parametric equations, including x equals to 4 plus 2t, y equals to minus 2 minus t, and z equals to 2 plus 3t, okay? And sub them into this guy here, okay? So you would get 8 plus 4t minus 6 minus 3t, take 2, take 3t, equals to 6. 8, negative 6, negative 2, cancelled. And you should get 4t minus 6t minus 2t equals to 6. T equals to negative 3. Notice that t can take any real numbers because the line is extending in 2 directions. It's not just like unidirectional from 4 minus 2, 2. The line could also go backwards, okay? That's why you can take t as negative values. And then finally, for the point of intersection, you need to chuck the t equals to negative 3 into x, y, z. X equals to 4, take 6, that's negative 2. Y is negative 2 plus 3, take negative 3 plus 3, so that's 1. And the z equals to 2, take 9. Next 7, okay? Coordinates will be negative 2, 1, minus 7, okay? So that's what I'm thinking. Okay, let's move on. Question 5, implicit differentiation. Curve defined by this thing, 6ey arctangent x over root 3 minus pi cos y equals to 0 has an x-intercept of 1. That means we have this point. X-intercept means y equals to 0. Find equation of the straight line that is perpendicular to the curve at this intercept. Give your answer in the form y equals to mx plus c. M and c are real numbers. First of all, implicit differentiation say we need to use product rule for this guy. So 6ey times dy dx times arctangent x over root 3. So this is like du dx times v plus u times dv dx. In this case, I'm going to write down root 3 divided by root 3 squared plus x squared, okay? Remember, that's the derivative of arctangent. Minus pi times derivative of y, cosine y is minus sine y times dy dx equals to 0. Right-hand side differentiated is also 0. Now we will make a substitution. Sub x equals to 1, y equals to 0, 6e0 times dy dx times arctangent 1 over root 3 plus 6e to the power 0 times root 3 divided by 3 plus 1, which is 4. And minus pi times sine of 0, actually plus, times dy dx equals to 0. So sine 0 is 0. We can cancel it out, this term. And we have 6 times arctan 1 over root 3 is pi over 6 times dy dx. And also you should have, let's say, 6 times root 3 over 4. So plus 3 root 3 divided by 2 equals to 0. So you will have pi dy dx equals to negative 3 root 3 divided by 2. And your dy dx at this point, 1, 0 is your gradient of tangent. That is negative 3 root 3 divided by 2 pi, etc. But the question actually wants the perpendicular gradient. So perpendicular gradient is m normal, which is -1 over m tangent. And that gives you 2 pi over 3 root 3, or 2 pi root 3 divided by 9. If you multiply the top and the bottom by root 3, and y, equation of the line, y equals to 2 pi root 3 over 9 times x minus 1 plus 0. So eventually this is 2 pi root 3 divided by 9, x minus 2 pi root 3 divided by 9, in the form of y equals to mx plus c, okay? So in my opinion, the first 5 questions are quite accessible, except for the definition, a little bit ambiguity here, concave up. But this one is reasonable. Let's have a look at the question 6. A cafe made a large batch of muffins. The masses of the muffins are normally distributed with a mean of mu grams and a standard deviation of 1. A random sample of 16 muffins were selected from the batch, and the sample mean was 25 grams. A 95% confidence interval for mu with z equals to 1.96. Answer correct to 1 decimal place. So your x bar minus 1.96 times standard deviation divided by n, and x bar plus 1.96 times standard deviation sigma divided by n. In this case, your sample mean is 25 grams minus 1.96 times 1 standard deviation, that's the population standard deviation, divided by root 25, which is 1/5. And the 25 plus 1.96 times 1 over 5. Notice that here, I'm just using round bracket, not square bracket, to be consistent with the formula provided by VCAA. So let's say 25 minus, if you divide 1.96 by 5, I suppose you should get a, let's say, 0.3 and 1.5. You have a 4, 6 here, and you could get a 9 here, I suppose. And what else? What else should I include here? 0.392. Yeah, 0.392. Okay, so that's pretty much what I need to use. And well, actually, bear with me. Sorry, I made a stupid mistake here. This is not 5. The sample size is 16, so it should be divided by 4. That's why I feel very strange. Okay, let's do that again. So 1.96 equals to, if I say 0.49 times 4. Yep. So if I divide 1.96 by 4, that will give me 0.49. And the other side will be 25 plus 0.49. Yep, that makes much more sense. So pretty much this is 24.51, 25.49. But that's correct to 2 decimal places. If I round them both to 1 decimal place, I would get 24.5 and a 25.5. Okay, something along this line. Okay, a different random sample of 25 muffins at this time, n equals to 25. So you have to really carefully read the questions. Was selected from the batch. The mean mass of this new sample was 25 grams, and a 95% confidence interval was calculated correct to 1 decimal place. By what percentage is the width of the new confidence interval reduced compared to the confidence interval calculated from the sample in part A? Well, I suppose confidence interval 1 was calculated by x bar. Actually, the x bar is 25 minus 1.96 times 1 divided by square root of 16. And 25 plus 1.96 times 1 over square root of 16. Confidence interval 2 is still at a 95% confidence level with the same sample mean value, 25, same z-score. But what we are subtracting or adding will be 1.96 times 1 over root 25. So 25 plus 1.96 times root 25. And this thing here and this thing here, we can actually compare them. So margin of error 1 is 1.96 times 1/4. And the margin of error 2 is 1.96 times 1 over 5. So if I figure out the ratio between them, margin of error 1 divided by margin of error 2 is 1.96 times 1/4 divided by 1.96 times 1/5. So you can actually get, let's say, 0.25 divided by 0.20, okay? Something along this line. Which means if you multiply everything by, say, convert everything into out of 100, you could actually get 1.25 divided by 1.00. So in my opinion, it has reduced by, let's say, 20% compared with the first one, okay? Actually, it's not quite like that. So margin of error 2 is actually 100 out of 125, margin of error 1. In fact, I would say this is 80 out of 100, okay? So for example, margin of error 2 is 80% of margin of error 1. Therefore, the old confidence interval has its width decreased by 20%. I suppose this is the intention to answer the question. By what percentage? Reduced by what percent? Okay. All right. So that's question 6b. Moving on. Question 7. The curve defined by the parametric equations x equals to at and y equals to t squared minus 8 log et, where t is between 1 and 3, is rotated about the y-axis to form a surface of revolution. Right. So if it's around the y-axis, surface area is 2 pi integration from t equals to 1 to t equals to 3. We will make an x here, and then x dash t bracket square plus y dash t bracket square dt. Okay, so this is what I'm going to do. Now, the surface area is just like 2 pi from 1 to 3. What's my x here? 8t. And what's inside the square root? Derivative of x is 8. So we've got a 64 here. X dash t is 8. And y dash t is 2t minus 8 over t plus 2t minus 8 over t bracket square dt, something along this line. Whenever we are dealing with arc length problem or surface area problem, we are trying to make a perfect square inside the square root. 64 plus 2t whole thing square, 4t square, minus 2 times 2, 4, 4 times 8, 32. So 32 times t times 1 over t plus 64 divided by t squared. Yep, that's pretty much what we can see. And you can see this middle term will be canceled out to minus 32. And eventually you get a 2 pi 1 to 3, 8t square root 4t squared plus 32 plus 64 over t squared dt. And the trick is you recreate a middle term in the form of a squared plus 2a times b plus b squared, something along this line, okay? You can just write, let's say, you've got a 16 pi 1 to 3 t times square root of 2t plus 4 over t whole thing squared dt, okay? Something along these lines. And the square root and the square will be canceled out. Also notice that the t value is between 1 and 3. Therefore, you argue 2t plus 4 over t must be positive. You don't need to add absolute value. So you should have 16 pi 1 to 3 t times 2t plus 4 over t dt. 16 pi 1 to 3 2t squared plus 4 dt. And that gives me 16 pi 2 on 3 t to the power 3 plus 4t 1 to 3, okay? What you can do here is like 16 pi times 2 over 3 times 27, if you sub in the 3, plus 4 minus 16 pi. Don't forget you have a 16 pi. 2 on 3 plus 4. Something like this. This is 9. Then you'll be able to get, let's say, an 18 plus 4, 22. 16 pi, 22. And then you'll be able to get minus. In this case, you can combine them together. 14 over 3, okay? And that's 16 pi 66 minus 14, okay? 16 pi times 50 divided by 3, okay? Something along these lines. So eventually you can calculate this number to be a very nice number, okay? Should be, hang on a second, let me have a closer look. I see. Don't work things out too quick. This is what I spot. This one should be 8 because 64 is a squared. This is 8, this is 8, this is 8t, okay? So you should have 3 times 8, 24 instead, and also plus an 8 here. That makes much more sense. Let's recalculate the answer. So it's always a good idea to go back and check what actually happens. Now let's do that again. 18 plus 24. That gives me 42. 42. And 2 on 3 plus 24 over 3. That gives me 26 over 3. And 42 times 3 over 3 minus 26 over 3. 126 minus 26 over 3. 100 over 3. So this should actually be 16 pi times 100 over 3. This is much nicer number. 1600 divided by 3. Don't forget your pi, okay? And that is the surface area. Yep, A equals to 1600, B equals to 3. So that is the final answer. Induction proof. Okay. I'm going to be lazy this time. Let this be my proposition N. For all N belongs to natural number, well, in this case, my N belongs to Z plus, positive whole number. Now, base case. P1 has left-hand side equals to 1 times 7, because I'm just looking at the first term, which is 7. And the right-hand side is 1 out of 6 times 1 times 2 times 16 plus 5, 21. So it's 42 divided by 6, that's 7, equals to left-hand side. Therefore, P1 is true. Okay? Assume PK is true for any K belongs to Z plus. That is also capital N, okay? i.e. 1 times 7 plus 2 times 15 plus 3 times 23. Until you add to K, 8K minus 1 equals to 1 out of 6K, K plus 1, 16K plus 5, okay? It is a good idea to actually write down, the proposition. And what's the next thing we need to do? Proof. Let me change another color. Prove that PK plus 1 is true. i.e. 1 times 7 plus 2 times 15 plus 3 times 23 plus K times 8K minus 1 plus K plus 1, 8 bracket K plus 1 minus 1 equals to 1 out of 6, K plus 1, K plus 2 times 16 bracket K plus 1 plus 5, okay? You need to add an extra term to the left-hand side. And then push these 3 terms onwards, like a 1 extra, okay? So now I'm trying to show, okay, left-hand side of PK plus 1 equals to 1 times 7 plus 2 times 15 plus 3 times 23 plus until K times 8K minus 1 plus K plus 1, 8K plus 8 minus 1. That's plus 7. Okay? And I'm going to make a big box here and explicitly mention use assumption PK right-hand side. So I'm going to substitute this here. And that makes it 16K, K plus 1, 16K plus 5. Don't forget to add K plus 1, 8K plus 7, something along this line, all right? Carry on the previous part. And you could actually take out a common factor, say, K plus 1. And that's 1 out of 6K, 16K plus 5. And you could actually write the other term like 6 over 6. 8K plus 7, something along this line, all right? The next thing is to show explicit manipulations for the rest of the term. For example, you could actually bring out 1 out of 6. 1 out of 6, k plus 1. You could have 16k squared plus 5k plus 6848k plus 42, 6 times 7. And 1 of 6k plus 1, 16k squared plus 53k plus 42. So the next thing is you need to notice the pattern here. Like when you observe the right-hand side of your target, which is this bit, you can pretty much see it's like k plus 2 times 16k plus 21, something along this line. So just double check. 16k, k to 21. 32k plus 21k equals to 53k. Yep, exactly what I want to see here. So I need to explicitly factorize the second quadratic term. Say k plus 2, 16k plus 21, which is equal to the right-hand side of pk plus 1. So therefore, if pk is true, pk plus 1 is also true. Make a conclusion. By the principle of mathematical induction, P of n is true for all n belongs to Z plus. That's what I'm going to write. So this question is very straightforward. It's just a tiny bit algebra thing. Make sure you know what you are talking about. Check your base case from n equals to 1. Assume pk is true. And write out your pk plus 1 fully, okay? And then use your pk. Make an explicit substitution and some manipulations to show the right-hand side. That's it. Question 9. In a population, the number of kangaroos P is modeled by the logistic differential equation. dp dt equals to 0.05 P times 10 minus P over 50. P is between 100 and 500, and T is the time in years after the population was established. Initial number of kangaroos was 100. Find the 2P dt squared in terms of P. So take the second derivative. You could actually rewrite your dp dt like P over 20, 10 minus P over 50. So what I'm going to do is I'll expand out everything. Okay, something like that. Actually, bear with me. It's not multiplying. That's just P over 2, okay? So your d2P dt squared is going to be first derivative, take the derivative with respect to P, multiplied by dp dt, okay? So what you're going to get first is half P differentiated, half, minus 2P over 1,000, which is P over 500, okay? And then you just need to write half P minus P squared over 1,000. Of course, there are other equivalent forms, but I could just leave my answer like that. This is one of the correct form, I suppose. But just don't forget about your dp dt after you take the derivative of this guy, okay? Because of the chain rule. Part of the graph of P against T is shown below. The graph contains a single point of inflection labeled A. In the context of the growth of the kangaroo population, what does the point of inflection at A represent? That means At this point, the population increases at the greatest rate, or we can say fastest rate of increase or rate of growth, okay? Something along this line. Okay. Solve the logistic differential equation to show that t equals to 2 log e 4p 500 minus p, and hence or otherwise find the coordinate of point A. In fact, what I'm going to do here is, you know, this A value has a population 250. I'm actually subbing this into the first part. Say t equals to what? P equals to 250, okay? Half of the maximum asymptotic population. So t equals to 2 log e, 1,000 divided by 500 minus 250. So that actually gives me 2 log e of 1,000 divided by 250, that's 4. Or if you wish, you could write log e 16, or you could write 4 log e of 2, etc. All right, but the question wants the coordinates. So coordinates, whichever version you like. So log 2 log e 4, comma 250. Now I just come back to solve this differential equation. So this is your differential equation. But I do need to make some reasonable manipulations here. And it's quite a bit marks, 3 marks. What I'm going to do is I'll take out a 150. So P divided by 20 times 500 minus P divided by 50. Now it's a good time to flip it upside down. 20 times 50, yep, 1,000. And also I should get P 500 minus P, something along this line. And we probably could make a partial fraction here. So if I've got a 2 here and a 2 here, does that work? 2 times 500 minus P, 1,000 minus 2P plus 2P. Yep, it's 1,000. Good, it works. So T equals to 2 lots of integration, 1 over P plus 1 over 500 minus P dP. In this case, I take a common factor out, 2 out, and integrate both sides. So I should be able to get 2 log E of P minus log E of 500 minus P. Add C. Notice that P is between 100 to 500. So P is greater than 0, and 500 minus P is also greater than 0. We don't need to put absolute values. Okay. And then we check in the initial condition. T is not, P is 100. 0 equals to 2 log E of 100 divided by 500 minus 100, 400. Subtracting log means dividing the argument. So you should have 0 equals to 2 log E of a quarter out of C. And the C is just negative 2 log E a quarter, which is 2 log E of 4. If you put the negative sign here and reciprocate your argument, eventually I can just put it back. Therefore, T equals to 2 log E dividing P by 500 minus P. plus 2 log E4. And you can just merge them together. P is 2 log E, 4P divided by 500 minus P. And that is a result required, okay? So you can see there are 3 stages of working, like flipping and finding the partial fraction, integrating together correct log terms, and justifying why you don't need absolute values. Eventually, you need to show your substitution to find the integration constant C, which cannot be omitted, and show some correct algebra to get the desired result for the show that question. And I explained how we could get point of inflection with the coordinates 2 log E4, 250. Last one. Use integration by parts to evaluate from 3/2 to 3√3/2 for arc sine x over 3 dx. Give your answer in the form a pi plus b, where a, b are real numbers. Basically, you could say your u dash is 4, and your u is 4x. Then your v is sine inverse x over 3. So b dash is 1 over square root of 9 minus x squared. And you don't have to put a 3 here, okay? It's not like arctangent, it's sine inverse, arc sine, okay? What I'm going to do next is integration is u times v from 3/2 to 3√3/2 minus integral from 3/2 to 3√3/2 v dash times u. So 4x minus square root of 9 minus x squared dx. Now, u times v, that is 4x times sine inverse of x over 3. Evaluated between 3/2 and 3√3/2. Notice there is a negative sign from the integration by parts formula, but what I'm going to do is put a plus here and push the negative sign together with 4x. I have a reason behind that. Or from my instinct, I know I need to do that. Because the second chunk of working, well, if you let your a equals to 9 minus x squared, your dA dx is negative 2x, which means your negative 4x times dx is 2 lots of dA. And when my x equals to 3/2, my a value is going to be 9 minus 9/4, which gives me 27/4. When my x equals to 3√3/2, my a value is 9 minus 27/4, which gives me 9/4. You know what I'm saying? Okay. So this chunk, I'm going to change it with a differential form, 2dA. The bottom can be swapped by root a, and then I just need to change the limits accordingly. This is the substitution method I'm trying to demonstrate. What you're going to do next for the first bit evaluation, you have to multiply 4 times 3√3 divided by 2. So 6√3 sine inverse of √3/2, subtracting, let's say, 6 sine inverse of half. We multiply 1/3 by 3/2, okay? The next bit, let me just use my green pen to write it out. Add. Now the bottom gives me 27/4. The top actually gives me a new value, new limit, 9/4. We have 2 divided by root a dA, something along this line, okay? So for the purple part, I should get a 6√3 times pi over 3 minus 6 times pi over 6. So eventually I should be able to get, let's say for the purple part, that's 2 root 3 minus 1 times pi. And that seems to be my, A value, okay? And then let's just do another evaluation for the green part. If you integrating 2 root A dA, this is some sort of evaluation like 4 divided by 2 root A dA. And that gives me 4 root A at a C, but this is a definite integral. So I'm just writing 4 root A from 27 over 4 to 9 over 4, something along this line. And that is like 4 times root 9 over 4, subtracting 4 times root 27 divided by 4. So you should be able to get, let's say, 4 times 3 over 2 minus 4 times 3 root 3 over 2. Okay, so that gives me, for example, 6 minus 6 root 3, okay? 6 minus 6 root 3. So that is my B value, okay? All right, that is question 10, I suppose. Yep, that's pretty much what I need to get. And hopefully you find this workthrough helpful at some stage for your preparation for the November specialist math exam. I'll see you in the near future. Ta-da!